Hi everyone. Thanks for joining, for being here after lunch. So thank you. Thank you so much. And what I will be talking today is about responsible AI and explainable AI, basically. Just a bit of the agenda. First of all, I would like to introduce responsible AI with the principles, which you probably may know. But I would like to go not deep, but I would like to make clear which are the main principles and how you can, as a developer, can use responsible AI. And after that, I will switch to explainable AI to talk about algorithm-centered explainable AI, what we used to know as SHAP, LIME, and so on, why you need explainable AI, and a new approach that there are a lot of papers going on in the last months. That is the human-centered explainable AI. That is not just about worrying about the algorithm, but also worrying about the human approach or how the human works in all this part. So hopefully you already had your lunch. So the main idea is to provide an analogy between the pizza. Let's suppose that you have a person that would like to have a restaurant and you would like to build your own pizza, and you will like that people will buy your pizza. I mean, what you should do in terms of pizza, but of course it's an analogy for a responsible AI part. So first of all, on the first principle, you probably will see out there that there are a lot of principles, words, a lot of concepts, but mainly there are four main principles. The first one is fairness, which is, in terms of responsible AI, it's fairness. So in the pizza analogy, let's suppose that we have a pizza and we are eating the pizza between our friends, and you have some toppings on the pizza. Here, for instance, I don't know, cheese with tomato, with something like that. And you would like to have these toppings equally distributed in each slice. So you don't want to favor a person to get more toppings compared with other person. In my case, if I'm eating a pineapple pizza, I don't want to get so many toppings related with pineapple. But in general terms, the idea of fairness is, and for AI, it's try to remove the biases. How you can remove the biases, how you can make your model more trustable to avoid majorities and so on. Basically, this is what fairness is. The second one is transparency, which is, in the pizza analogy, it's you need to show the recipe, not the recipe, but the way you used to cook your pizza, for instance. We have Detroit-style pizza, we have Napolitana pizza. I don't know if there is a Raleigh pizza, but that could be another pizza that you should say to your customers that you need, okay, our pizza is like the Raleigh style, or is the Detroit style. Do you want to talk? Yeah, sure, go ahead.
Hey, excuse the interruption. My name is Tyrell James. I'm piggybacking off of fairness and transparency. If you are playing the game, I have the code for you. The code for the game is feature 23. So if you're playing the game, the code is feature 23, all lowercase, I believe, okay? So if you don't know what I'm talking about, it's all cool. I'm just rambling, whatever. Somebody else is smarting you up to it. But if you are playing the game, the code is feature 23.
I don't know what you're talking about, but
It's all good. I'm just wandering.
Thank you. No worries. So going back, the transparency is you need to say which kind of pizza you are building. And same thing for AI, is you need to at least say when you are building a model which kind of technology are you using. If you are using LLMs, if you are using GPT, or if you are using BART, or if you are using decision trees. I mean, you should probably make it public to some audience which kind of models you are using. And it helps you people because the main goal of those principles and the responsible AI is you need people to trust on your application or to buy your pizza, for instance. The third one is accountability. Someone has to be responsible for that. So in the pizza analogy, if you receive a pizza that is overcooked, you need to talk to someone. I mean, someone has to replace your pizza. Someone will have to give you a new pizza. Or even if you don't like it, even if you ask for pepperoni's pizza and you get a pizza with pineapple, and you can probably say, okay, I asked for another pixel for other kind of pixel. So someone has to be responsible. And in AI, it's very important, this part, because now with LLMs and with all the hype with NLP, when you are building a solution, someone has to be responsible for the answers that you are getting. And same for computer vision or for all the use cases. But this is a very important part that probably for the AI developers, we probably would like to build a solution that works well on something. But we don't think in that part of, okay, who should be responsible for that in front of customers. The last one is privacy and data protection. This is probably related with security, but with the pixel is, if you have, it's how you protect the data of your employees, for instance. You will not be sharing publicly the name of your chef. I mean, you probably will do it, but you probably will not do it with all the employees. And same for your providers. You will not share the information or the names of your providers. Same happens with AI. So you need to keep the privacy. Like if you are training a model, you need to protect the data of this model. So you need to make it public that you are working with some particular data, but you need to make it private. And similarly for privacy, privacy could be more related with security. I mean, when you are inferencing or when you are working with your model, it's probably, you have to have tools to protect it against attacks and so on. The conclusion at the end is you will have a pizza or you have a restaurant that most people will buy or will trust on you. And same happens for AI, for when you are developing an application. Seems to be very easy, so they're just 4 principles. But the thing is, which tools we as a developers, we have to use that. Well, from the developer perspective, we can talk about 5, in fact, main tools. The first one is you have to remove the biases. Talking about the fairness, there are tons of open source projects or tools that can give you the chance so you can see if the data set that you are training your model is biased. These tools can help you to debias this data set, but there is a trend that is very related just with fairness, just to remove the bias. And the most well-known tools are the IBM i360 and the Google What If. Just in case if I have a slide after that to explain. But it's very simple. So if you have a data set with gender information or with ages information, you don't want to make the model to perform better for some particular group of your data set. You would like to make it equally distributed for all of them. But there is not just related with, because it's easy to detect the bias when you have in your data set features like gender or marital status or so on. Depending on the data that we are working, we also need to detect the proxy variables. So, for instance, if you have the marital status of the person, someone can infer the sexual orientation of this person. Same for the geographic patterns. So with the geographic patterns, you can infer, some people can infer the ethnicity of this person. So you're not just only, and this is very related with each particular use case, but it's not only with the features itself, it's just what you can imagine or what you can get from other features to infer information or to get information. And this is where it starts to being some complicated and sometimes because it's not so easy to remove some biases because it's not just the feature. It's the feature plus tons of things that could help you, that could infer in the middle to get a bias, right? So this is why that there are out there tons of tools to remove the biases. And this is why fairness is a very hot topic in research because it's not easy to detect it. The third one is data model governance. Of course, you need to document if you are probably if you use Hugging Face, you will see that there is the model cards, where they try to explain, okay, this model was trained in this particular data, which is from a public data set and so on. So you need to do that so people can use your application or your model. So you need to make it public. And same for the data sets and the data sheets. So there are some governance part that it's important. Of course, all of them are important, but you need to explain it, not just, I create a model, it's working, and that's it. It's not how it works, because it could work for us as a developers, but for instance, when you want to implement that, and you need to make your application open to the real world, and you need to use it, you can probably have some problems, of course, because regulations, there are a lot of problems, so you need to make it public, so people can trust you, basically. The fourth one is explainable AI. I will talk later more deep about explainable AI, but for me, it's the best tool to help on people to build trust. When we create an application and we need to build trust between the users and the developers and the audience, explainable AI is a very important tool that can help you on that. And same from the biases. It's not easy to find an explanation of the models. And in the last one, it's protect the data when it's implemented. Safety, security. There are some projects and tools or ways to use an implementation that could be federated learning, for instance. When you are running your model, you need to protect data when the model is deployed. So you need to create mechanisms to protect the data and also the model. So it's not just for principle and that's it. It's much more than that. Here we go. That's it. So sorry about that. Here we go. This is just a screenshot that I wanted to show about the IBM. There are a lot of similar toolkits to check the bias, but what you can see here is that there is a data set. It doesn't matter the details of the data set, but this is for the German credit scoring. So what you can see and what this tool gives you is it gives you if the data set is biased or if it's fair. So depending on how the model performed or how the data set is distributed, they will say, okay, you have your data set that is just oriented, and most of the data is, I don't know, 80% of your customers are oriented on one age, for instance, or one site. So your model will be biased just for this particular audience. And it's not an AI fault, because when you are training a model, the model is learning from scratch. When it starts from scratch, it's learning from the most data you have. So it's detecting patterns. So if you like to represent the minorities in the model, you need to find a way to equally distribute, or there are alternatives that you can do to equally distribute the model. This, what will give you is, before training the model, is a tool that can just look into the data set. You can see if your model is trustworthy or not, or if your data is biased. So going now in details of explainable AI, let's suppose that we already work with the data. We know that our data is not biased. And suppose that your data is not biased, and we have a model. We train our model, like is this box, and it's to detect, very simple, if an email is a fraud or is not a fraud. Let's suppose that the model says that it's a fraud. You need to say, or you would like to understand why the model took that decision. You need to explain, or most people can answer or can question, okay, why is it spam? Based on what? Based on something that you want, because you don't like it, or whatever. So you need to find a way. There are other alternatives, that is going even further about just the explanation, is that why not something else that is just give you a size between, okay, I wanted to give you that answer, but I didn't give you that answer, so I gave you that answer based on what? These are going further, of course. And the last one is the most important. So should I trust you? But before, sorry, if you have an end user that they would like to collaborate with you, and they may say that your model is not working as expected, so how can I help you as an end user to fine-tune the model or to give you feedback? This is just an overall. Of course, each question or each particular topic, it's a huge way of research. But if we start from scratch explaining what is explainable AI or explainability, if you see in the documentation, the terms are not aligned, but probably we can all agree that explainability is the idea to provide some insights to a targeted audience. So what it means is that the responsible AI or the fairness, for instance, the part of the fairness, it's clear, it's remove the bias, and it's the same bias for everyone. But explainability, it's not the same to everyone. So you need to build an explanation for each particular person or audience that you are working. We can divide this audience in 3 main groups. The first group that is on the top is the regulatory perspective. Sometimes you are forced to explain why your model took that decision, like GDPR, like regulations, and more regulations that would appear in the future, hopefully, to obligate the models to explain the decisions. So this is one group of explanations. The other ones that are in the middle are the end users and scientific perspectives. The difference between them is that the end user is the user that is consuming your application. Any application that you are using, let's suppose that you are using Uber, or DoorDash, or Uber Eats, or whatever, let's suppose that you would like to know why they assign you one driver instead of another driver. And you have no idea about the AI, you are just using Uber, you're just asking a cab to go to your home. So you need an explanation for that. You will need an explanation for that. This is one group of explanations, which is to people that has no idea about AI, but they need an explanation. The other group, that is, we can say these 3 groups. Oops. It's 3 main groups. These are the technical groups. So when you are working with AI and you are developing a model, when you are a scientist, if you can get insights about how the model is performing, but underneath, like if you are using a deep learning, okay, why internally, what are the weights that the model used to take that decision? It's a very technical conversation, but it's useful for developers or for scientists that are working to improve the models. So there are mainly 3 groups of explanations, and it's as I said in the previous slide, you cannot solve them using the same application or the same toolkit, and you cannot provide the same explanation to all of them. Now, it seems to be a very complicated slide, but I promise it's not so hard. If we think the explanation in the middle, oh, come on. I will not use it anymore. If you see the explanation in the middle, you will see that you have 3 main groups. You have the data explainability, which could be related with fairness, but it's how you can remove the overfitting, how you can reduce the overfitting of the data, if it's equally distributed. This is more related with data visualization. And there, the mod explainability, what I said before, is that you would like to go deep on the model to understand the weights, the measurements. If any of you is familiar with transformers or with LLMs, the attention layer, how the attention layer worked in detail. This is information that is very useful for the scientists to make the models better. There is a group, and the goals are different. If you see in the goals, even if they are very tiny, you can see that the goals are different. One of them, they are trying to build confidence. The other ones are trying to build information to make it more causality or interactively and so on. There are a lot of concepts over there. And the last group, which is the post hoc explainability. So you have a model that it's trained, and you need to provide an explanation after the model was trained. And this is where I will go in details. That could be the end users of your application, or it can be also some people working with AI. But you need to provide different kind of explanations. The post hoc explanation is what is most common usually, and there are some tools that I will show later that people used to use it. So it's much better now that I don't have the thing. Talking about models, we are in a moment when the models that we are creating, they are getting more complex and they are getting less explainable. So they are more complicated to explain what's going on inside. You will see with transformers, with GPT, with so on, and it was with deep learning. Even deep learning, we cannot visually see why the model is behaving as it's behaving. So it's not visually, you cannot visually see. And if you go from the very old times, you have the decision trees that we are still using the decision trees, of course, but they are very visual. I mean, it's a tree, so you can see which path of the tree the model took to give you an answer. So it's very visual, it's very explainable. But we are in a point that we would like to implement those models that are there, with explanations that can be here, that can be in the very explanation. It's a challenge, and this is why responsible AI and explainable AI mainly, it's growing in research, because we start seeing ChatGPT, a lot of applications that most people would like to use it, they want to use it, they are paying, let's say, to use it, but there's no way to exactly explain what's going on inside. So this is why there's a lot of research, because the pressure is, I would like to use LLMs, but I can't explain why the model did that. The ideally will be, okay, let's use decision trees at the end, so it's great, but you cannot, of course, you cannot use a decision tree for NLP tasks, of course. And the research and all the academia is going to more complex models instead of building things on the middle. I mean, there are multiple trends, of course, but what we can see is that they are most on the most complex part. So you would like to explain a model. You have two main ways to explain a model, two general ways. The first one is the explanations could be global or local. The main difference is what we used to call a model explainer global. It's you have your model, which could be a transformer or it could be a neural network, and you build a parallel model which is explainable. Think like you have a deep learning or you have a transformer and you have building in parallel a decision tree model that behaves in the same way, that gives you the same results that the deep learning network gives you. But if you use this model, you can explain it and you can give the answer to the person. This is very challenging because you need to build a new model. And there are, for instance, if you are familiar or if you heard about Lime, Lime is basically what they do. Lime is an open source toolkit that they create a parallel model and they provide similar explanations on that. But this is not something that you can do it every time because it takes time to train, because it's not just one model that they train. It has several kits of explainable models. They train the model, you need to give the data. It's not so easy to use it. I'm not saying that's not applicable, but it's applicable in most of the cases, but some cases it's not. And there are others that is local. So with the local, you have the model, and you treat the model as a black box, and you see how the features affect the output. And you find a way to explain how the input affect the output, and just looking to the input and the output, you can explain which feature was most important compared with others. And this way to explain a model is what we call the post hoc explanations. There are tons. I mean, I just wanted to show that there are tons of them. What you should use, most people start just with Lime and SHAP. But there are multiple trends in the middle, like SHAP improved or different toolkits. But the concept is mainly, or you build a new model, or you treat the model as a black box and you see what's going on between inputs and output. And this is what SHAP does. SHAP, for instance, in that input, you have age, sex, BP, BMI, which I have no idea what it is. But the output that you have is the weight of each particular feature in that decision. So this is why we call it local, because you have an answer, you have an output, and what SHAP will give you is what or which were the most important features for that particular decision. It's not global, it's just for this particular decision, which sometimes is great and sometimes cannot be so good. I work at Intel, and I didn't introduce myself, I think, at the beginning. I work at Intel. My role is AI open source evangelist. So I used to work or collaborate in the open source ecosystem and the tools that Intel is providing and contributing to the open source ecosystem. And one of the tools is AI explainable, Intel explainable AI tools, which is a set of tools, basically, that uses Lime, SHAP, and so on. But the idea is to try to centralize. It's not the main idea, but we try to centralize all the tools that are over there, and we try to make it in a one particular place. Just as an example, I mean, I could run a demo, but I would run out of time. But let's suppose that we have a heart disease data set, that you have features, and you have a target. The target is something related with heart disease, which I have no idea, but it's fixed, normal, reversible, and I don't know, heart information. So you train a model. First of all, you define your neural network, as you do on TensorFlow or PyTorch, whatever. You train the model. You get your model, which is from now, now it has nothing to do with this toolkit. It's just you training your model. And after you train your model, you run the explainer. That explainer is running SHAP, of course. What will gives you is, okay, for this particular answer that you gave me, which were the most important features to take that decision? And in this case, it says that 3 tablespoons, I don't know, what was the most important, and also the age was a bit important. And the other ones, the oat peak and the talak, which I don't know, and the cholesterol, I think that is, were less important, has lower importance. And this can be useful if you're a doctor and you are running this test and you would like to know, okay, you said that this patient will have a heart attack in the future. Okay, why? Okay, because 3 tablespoons. I don't know what it is, but it's 3 tablespoons, which can be useful for the doctor or not. And even for healthcare, it's very important because when you're implementing models, even if they are simple, doctors need an explanation. I mean, healthcare is a very it's a very deep field on explanations. And imagine that it's even hard to use the computer vision's explanations to detect tumors and everything. And imagine if you would like to implement something related with LLMs. So it's one thing is the technology, and the other thing is how you implement the technology, right? Another use case is, okay, that's okay with a tabular data set, but what happens if you have an NLP solution? Same thing. I mean, you will train your BERT which is in this case, but it could be GPT or whatever, and you would like to run the classifier. That particular case is a classifier, so you give a phrase to the model, and the model says it's a sentiment analysis. It says if the phrase of the paragraph is positive or negative. And the model what gives you is which parts of the phrase of the paragraph were positive and which part were negative. They weigh all the results, and they say if your phrase is positive or negative. This can be useful if you would like to find which words the model is detecting to say that something is positive or to say that something is negative. It's just a visualization. It's just very basic. I mean, I'm just trying to introduce the topic. But of course, if you would like to detect ironies, it's very complicated and so on. But at least you can see it, why the model took that decision. And it's okay. We have an explanation. We have the ways to explain the things, but the main problem here, but it's not a problem, but the main challenge is that you need to give those explanations to humans. It's not a machine. It's not another machine. It's not another computer. It's a human. So when you are doing your explanation, you need to think on three main principles, which is the AI part, of course, but there is a social science in the middle. You need to explain, you need to know what the other person needs and probably how the person could behave with your answer or with your explanation and so on. I mean, it's not just technology or tech. This is where it starts to be interesting. And what is the best way to know which customers or what people want to hear? Making surveys. It seems simple, but it's just, if you are developing an application, just ask them if it's useful or not. And you will get some surprises if you do that. Like, for instance, what I wanted to introduce is this paper, which is Help Me the AI, which is a paper that was developed by Intel Labs, which is the Intel research team. And basically what they did is they pick an application, which is Merlin. Merlin is an application to detect bird species. So if you like to know which kind of bird is, for instance, I'm from Canada, so I took that picture and I said, okay, could you please detect which kind of bird? And he said Canada goose, so it was working. But they picked that as an example and they say, I would like to ask to the end users of the application what they think about the explainable AI. I mean, if they think that it's useful, how they intend to use. I mean, the paper is very interesting because it goes in details on each particular question. This is just a highlight. But basically what they did is they perceived 4 kinds of explanations to end users. They give, for instance, the heat map-based explanation. So you have the picture of the bird, and what you will get in the heat map is, of course, in red, the most important or the most relevant part to the algorithm to say that this bird is a particular kind of bird. Could be the legs, could be whatever. And the second one is an example. Instead of giving a heat map, they give you, for me, this is a Canada goose because it's similar to this other's Canada goose. The other one is concept-based, which is more technical, but it gives you, for instance, if it has a white body, if it has a yellow body, which features were important to take that decision. Remember that we are giving that explanations to end users, to people that, for instance, they don't know what is a heat map, let's say, right? It's not AI people or developers. And the last one is the prototype-based explanation, which is you have the image, and you have to say which part of the image was important to identify the bird. And the perceptions were, between the audience, it was very high AI people and low AI people. The high AI people thought that the heat map was great, was helpful, and it was very useful. But for the people that has no knowledge in AI, they said that it's related to weather. So they didn't understand that. The second one is the concept-based explanation. Of course, for if you know AI and if you are working in that details, it's great because you have a number, you have details, you have everything. But for people, or for low AI people, there's a bunch of numbers, words, things that doesn't make any sense in their minds. Basically, what we are saying is that there is a gap in explainable AI. Most applications, AI and even explainable AI tools, they were developed by AI tech deep developers. So if you would like to move that to the end user or to person that is not high in AI or they don't know a lot of AI, they will not understand it or they will not use it. And at the end of the day, what will be worse is that they will not trust on your application. So just the main goal here is that we need to fill that gap between the creators, which is very knowledgeable, very high AI, and the end users that have not AI, low AI, right? Even if they are curious or not, we need to start thinking every time that we are building a solution using explainable AI, we need to think that, okay, who is the end user? And it goes back to the beginning that we have an explanation, we need to be aware to whom is this explanation. Recapping and putting all together, we have explainable AI, which is the circle that has multiple toolkits, details, tools, implementation, a lot of things we have in explainable AI. And this explainable AI workflow feeds or using the concepts of responsible AI, which is fairness, privacy, accountability. It was ethics also in the middle that I didn't mention, but sometimes it's considered as a principle, sometimes it's not considered as a principle, but it's important, of course. Putting all together, you will get the responsible AI, or you will meet the responsible AI goal. This is always changing, the names are changing, the concept is changing, but mainly the concept is you have the principles, you have some principles that could change, and you have some tools that can help you. But the main goal is what we are seeing in the last years is that explainable AI is the main tool to feed the responsible AI concept. So I think I'm on time, okay. The conclusion at the end, there is no one-fits-all solution. Even if you have a good application for healthcare, probably this application doesn't work for finance, and vice versa. Real users, every time you would like to implement that, talk to users, make surveys, try to think what the users would like to know. Human cognition, of course, could help. The main point here is explainable AI has to answer the why, not just the what, because this is the main point of explainable AI, is why did you take that decision and based on what did you take that decision. And explanations is a very important tool for when you are developing an application in AI. It's not just meeting the accuracy or being perfect. Of course, it's important, but the explanations of the model should be part of your value proposition. There is a call to action. Basically, what I would like to mention here is if you are working with explainable AI, or if you would like to learn from explainable AI, the good thing is that there are a lot of open source toolkits that you can start working and you can learn from that. And it's growing. It's a community that is really growing. So contributors, they are always welcome. And also for multiple domains. Because you can find, for instance, that for healthcare, there's a huge community for healthcare, but probably there is not for finance, or there is not for, oil and gas. And what will be useful also is when you are contributing, try to put together and try to see if something that is working in healthcare can work in another vertical. And And that's it. I mean, right, it's open source, so the only thing to grow on the explainable AI and responsible AI community, it's through the open source collaboration. So it's basically why we are here, right? And that's it. Thank you so much for your time.